Okay, so today's notes are on forming ionic compounds. So, ionic compounds form when metals react with nonmetals through an exchange of electrons. Okay? So metals will lose electrons in reactions to form positive ions. Nonmetals will gain electrons to form negative ions. Okay, so let's do some quick examples. Yeah. Yeah. Okay. So I think I want to just do this with examples. So let's do a few examples. So example one, let's do a really simple one. Let's react lithium metal with chlorine. So if we had lithium metal and we had chlorine and we put them near each other under the right conditions, they would react. And lithium would tend to lose its electron and chlorine would tend to gain one electron. And what that would do is it would leave behind a positive ion nearby to a negative ion. And you would have an attraction between these two items. Okay? And you would form the compound lithium chloride. And you don't actually have to draw these in because what ends up happening is overall there's no charge, right, on this compound. This is plus and this is minus, but those charges cancel each other out, and you have a neutral compound. Okay. So a couple things to note. The symbol LiCl, what does that represent? Can anyone tell me what LiCl represents? Like, what does that mean? Yeah. So both elements forming a compound together? Yeah, so it's what this shows is it shows essentially the ratio of lithium to chlorine in a lithium chloride crystal. Okay? So it has a name. It's called the formula unit. Okay? And all it's really saying is that lithium is in a 1-to-1 ratio with chlorine. Okay? Do you guys take ratios in math class? Have you ever taken ratios before? Like, what is the ratio of cookie to filling in an Oreo? Yeah, that's right. So cookie to filling is 2 to 1. So what that means is if I were to take 10,000 Oreos, right? If I were to take 10,000 Oreos, I would know that there are 20,000 cookies, right? And 10,000 cream fillings, okay? So in an Oreo, it's 2 to 1. So it's a similar concept, okay? In this one, it's 1 to 1. I'm trying to think of something that's in a 1 to 1 ratio. Hamburgers, no. Shirts to people. Oh no, that doesn't work either. No, cheese to crackers. Okay, cheese to crackers tend to be, unless you make a cracker sandwich, 1 to 1. Okay, tend to be. That's cheese. That's cracker. That's 1 to 1. So what we're saying here is there's 1 lithium for every 1 chlorine. We're not necessarily saying there's only 1 lithium and only 1 chlorine. We're saying in our crystal there will be an equal amount of lithium to chlorine, right? Because what you have to remember is ionic compounds are well, they form giant crystals, right? So if we were to start drawing them out, you're going to end up with this. And I think we looked at this maybe last class, but I'll just refresh your memory. It's going to build itself up like this, right? So there's always going to be an equal amount of positives and negatives overall. Now this changes if, you know, if some of these things don't carry a one charge, then you're not going to get a 1 to 1 ratio. Now this is going to form into a nice cube of closely packed, you know, little spheres if you want, little ionic spheres, and it'll grow into a crystal. So what if we have another example? Example 2. What if we were to react magnesium with bromine? Well, this is a bit different, right? Remember, magnesium, yeah, sure, magnesium has 2 electrons around it, whereas bromine has 7. Okay, so 2 ways to look at this. If we were to just look at the ions formed right now, magnesium forms a 2+ ion, bromine forms a negative ion, okay? Bromine will accept an electron, okay, but it can only take 1, right? So if I look, magnesium, in order to have a full shell, has to give away 2 electrons. So what we have to do is we have to make sure that all the shells at the end of the day are full. So the way to do that in this scenario is to have 2 bromines there. So we're going to have a different ratio, and if I look over here, you can sort of see the same thing happening. For every 1 magnesium, I'm going to need 2 bromines. Okay? In chemistry, to say 2, we use a subscript, so there's 2 bromines. Okay? So what we end up with then is we end up with the compound MgBr2. Okay? Do I have to memorize any of this stuff, or can I find it all in the periodic table? Yeah, I can find it. If I have a periodic table, I can essentially tell you, just by looking at it and figuring this stuff out step by step, what any 2 metal and non-metal reactants will form. Okay? I'm going to give you guys one to try. I'm going to try to make it a hard one. What if you guys reacted calcium with nitrogen? Can you give that a try? Okay, so what we saw for the last one, oops, calcium forms a 2+ ion, nitrogen forms a 3- ion. So what we do is we look and see what's the lowest common multiple of these 2, and that equals 6. So that means if we take 3 of these, 3 times +2, that's going to give us a +6, and then 2 times 3- gives us a -6, so we end up with Ca3 and 2. Of course, the other way of doing that is just this way here. So we can keep on just building as we go. So if you don't actually know, we might not have these guys here, right? You might just start like this. I just want to put this down in case anyone's missing today so they can look at it online. So what we'll have is we'll have this. Okay. Draw these as X's, and 1 and 2. Oops, 1 and 2. And we need another one. We can only accept one more. So now it's 3 minus. It's happy. Happy face method. This is now 2 plus. Okay, this has only lost one of its electrons, so we have to add another nitrogen on here in order to accept it. It only has one more to give, so we got to add one more calcium. And that'll fill up the last 2 spots. So 3 calciums for every 2 nitrogens. So final answer, CA3 and 2. Let's try one more. How about this? Let's go with aluminum plus sulfur to make aluminum sulfide. Okay, try that one on your own using whichever method works for you. Start probably with the Lewis diagrams. Okay, so have a look, check your work. You need 2 aluminums to go with 3 sulfurs. Aluminum forms a 3 plus ion, sulfur forms a 2 negative ion. Lowest common multiple of these 2 is 6. So you have to have a total of 6 positives and a total of 6 negatives. Okay? So to get 6 negatives, you need 3 sulfurs and 2 aluminums to get 6 positives. And there you go, Al2S3. How many people got that? Hands way up. Awesome. Sounds good. So I'm going to give you some homework and call her a day.